Hello dear aspirants, this is Dr. Sourav Sir's class. We are solving some questions about statistics. So this question is telling us that we have to consider the one-way fixed effects of the ANOVA model, and this is telling us that Yij is equals to mu plus alpha I plus epsilon ij, where j is equals to 1 2 dot 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 ni, and I is lying between 1 to k. Okay, so where the errors epsilon ij's are uncorrelated with mean 0, and finite variance, that means sigma square, is always positive, let our yi bar equals to 1 by ni summation j equals to 1 to ni yij for I equals to 1 2 3 dot 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 k. Then what will happen? Then which of the following statements are true? So there are four options of this question. So first option is telling us that 1 by summation I equals to 1 to k in I into summation of I going to 1 to k and summation j going to 1 to ni. Okay, it's a double summation. Yij is an unbiased estimator of mu. Option 2 is telling us that 2 mu plus alpha 1 plus alpha 2 is an estimable linear parametric function. Option 3 is telling us that mu plus alpha 1 plus alpha 2 is an estimable linear parametric function. And option 4 is telling us that 1 by n2 summation j equals to 1 to n2 of the minus of y2j minus y2 bar is an unbiased estimator of alpha 2. So this is the given question to us. So what can we do? So we have to first understand the given model which is given in the question. So our model is this. That means, yeah, sorry, yeah. So our model is this. So we can write it in this side. So Yij equals to mu plus alpha I plus epsilon ij. Where our j is what? J is lying between 1 2 dot 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 in I, and and I is lying between 1 2 dot 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 k. Where our mu is the overall mean, and alpha I is the effect of the ith group, and my epsilon ij is can be approximated by the normal distribution at this. Sorry, that can be approximated by this. The errors are independent with mean 0 and variance sigma square. So the sample mean for each group will be what? They will be yi bar equals to 1 by ni summation j equals to 1 to ni. That will be what of my yij, and I is lying between 1 to dot 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 k. So now we have to analyze each statement. So our first statement is telling us this thing. So we can say that this thing is an unbiased estimator of mu is my first option. So uh, we can use, so the given estimator is the overall mean of all observations. So y bar overall will be what? Y bar overall equals to my summation I equals to 1 to k, and the summation j equals to 1 to ni is yij by what? By that will be summation of I equals to 1 to k ni. And then the expectation of y overall will be what? Y bar overall will be what? Mu plus summation I equals to 1 to k ni alpha I by the summation of this thing. Yeah. So this is the expectation of y bar overall. So now under the constants, that means summation I equals to 1 to k n I alpha I equals to 0. The sum to 0 constant for group effects. The estimator is unbiased for mu. So our option A is a correct statement of this question. So we can mark it's a true option. Okay. So now we have to think about our option 2. So option 2 is telling us what? 2 mu plus alpha 1 plus alpha 2 is an estimable linear parametric function. So a linear parametric function is estimable if it can be written as a linear combination of the observations of yij. Here we have this thing, that means 2 mu plus alpha 1 plus alpha 2 will be equals to the expectation of what? 2 y bar overall plus y1 dash overall plus y2 dash. Okay, yeah. So now which is a function of observable quantities, so thus it is estimable. So it is my estimable and our option B is true. So we can mark this is a correct option of this question. Now our option 3 is telling us what? Our option 3 is telling us that mu of mu plus alpha 1 plus alpha 2 is an estimable linear parametric function. So similar to the above, as our mu plus alpha 1 plus alpha 2 can also be written as a function of the group means y I bar and the overall mean y bar overall. So thus it is estimable. So our option C will also be correct option of this question. So now we have to think about our option 4. They are telling us that 1 by n2 summation from j equals to 1 to n2 and y of 2j minus y2 bar is an unbiased estimator of alpha 2. Okay, so the given term which is my y2j minus y2 bar has mean 0 because it represents the deviation from the group mean y2 bar. So it does not provide information about alpha 2 because our expectation of this thing y2j minus y2 bar equals to what? Equals to my expectation of y2j minus expectation of y2 bar. That will be equals to what? That will be equals to mu plus alpha 2 minus of mu plus again alpha 2. So that will be 0. So thus it is not an unbiased estimator of alpha 2 as we are getting a scalar value which is 0. Okay, so our fourth option will be cancelled out. So the correct options of this question are my A, B and C. Hope you understood guys. Thank you.